Greetings. In this video, we are going to see about Markov process, Markov chain, and few concepts related to all these to solve problems. First, let us see what is Markov process. A random process x of t is said to be Markov process if it satisfies the condition, that is probability of x of tn less than or equal to xn, given x of tn minus 1 is equal to xn minus 1, x of tn minus 2 is equal to xn minus 2, and so on, x of t1 is equal to x1. If this probability, conditional probability, is equal to probability of x of tn is less than or equal to xn, given x of tn minus 1 is equal to xn minus 1. So, how can you interpret this definition? Here, a random process x of t is said to be Markov process if it satisfies this equality condition. What does it mean actually? Probability of nth present time. Tn denotes the time. Okay, so in the interval 0 to tn. So, if we take it as a future, probability of happening of future uh, given all the past, tn minus 1, tn minus 2, etc. tn. All these time intervals denotes the past happening. So, probability of happening of future given all the past is same as probability of happening of future given the present alone. That is, x of happening of x of tn less than or equal to xn depends only on x of tn minus 1 is equal to xn minus 1, not on tn minus 2, tn minus 3, etc. t1, not on the past. Okay, so Markov process is nothing but a process in which happening of future depends only on the present, not on the past. Then we say such collection of all such random processes as Markov process. Then what is Markov chain? A random process or Markov process x of t is said to be Markov chain if it satisfies this equality condition, that is p of xn is equal to an given xn minus 1 is equal to an minus 1, xn minus 2 is equal to an minus 2, so on. X naught is equal to a naught is equal to p of xn is equal to an given xn minus 1 is equal to an minus 1. What is the difference between these two definitions? The previous Markov process definition as well as in Markov chain definitions, what they imply is the future depends only on the present, not on the past. Same concept. But what is the difference between these two? Markov process is a definition with a collection of all random process in which time t is continuous. Okay. Markov chain is a collection of all random process x of t following this condition, whereas t is discrete. That is, time is discrete here. Okay. So, x of t in Markov chain takes only discrete values. Okay. So, here the values of x of t, we denote it as a1, an minus 1, an minus 2 up to a naught. So, all these a naught, a1, etc. an, we call it as states of Markov chain. So we can just imagine these two as Markov process is nothing but is like moving of a snake movement, where the movement of a snake is continuous. Okay, at a particular time we cannot say where exactly the snake is. It is a continuous process. But Markov chain is like a movement of a frog. How frog moves? It just jumps from one state to other state. That's why all these here we denote a naught, a1, etc. an. All these a naught, a1, etc. an are called states of the Markov chain. Then x naught, x1, etc. xn, all these suffixes denotes the number of state space, that is number of steps it takes to reach the particular state. So this xn is n, the particular n denotes the steps. Okay, number of steps taken to reach the particular state. This is called state. So we can say it is nth state. An means it is in nth state. So from n minus 1 to here, if you say from n minus 1th state to nth state to reach this, how many steps it has taken? X minus 1 steps to xn. So what is the difference? 1 step. Okay. So the suffix x suffix of x denotes steps, number of steps taken, and suffix of n denotes number of in which state it is in. Okay, the state. Okay, so based on all these, we have to be clear with few concepts called transition probability. What is the meaning of transition probability? What is the probability for the transformation from one state to other state? For example, if we take it as xn is equal to aj given x naught is equal to ai. We call it as transition probability. What is the transition taken place here? Transition from state I to state j. We have to read from here to here because it has happened. This is what going to happen. So we have to read from right to left. Okay. So transition from state I to state j. So we denote it as Pij. In how many steps? This denotes steps. No. In how many steps? 0 to n. So number of steps taken is n. So we call it as n step transition probability. So this is called n-step transition probability. From this, we can define what is one-step transition probability, two-step transition probability, and so on. So can you say, how can you denote one-step transition probability? It is Pij1 or simply Pij. It is called one-step transition probability. And it is denoted, it is defined as P of x n is equal to aj. Move from state I to j in how many steps? One step. So the previous should be xn minus 1. So from state I to j it moved. The number of steps taken is just one step. N minus 1 to n. So this is called one step. If you want two step, we can say it as xn is equal to aj given xn minus 2 is equal to ai. Like that, we have to maintain the difference between these two as n step. What is n? Correspondingly, we have to maintain the difference. Okay. I hope now you are clear with n-step transition probability in general. Then what is transition probability matrix? Okay. So all these transition probabilities we have discussed, no? N-step transition, two-step transition, one-step transition. So collection of all these transition probabilities, put in collection of all these transition probability in rows and columns as an array. We call it as we write it in the form of matrix. We call it as transition probability matrix. So from n minus 1th state to nth state. Generally, transition probability matrix will talk about P. P means we'll talk about transition from previous to the next state. So the order of transition probability matrix, it's actually a square matrix, n by n matrix. This n depends on the number of states. If two states are given in the question, P will be of order 2 by 2. If three states are given in the question, then P will be of order 3 by 3. So TPM is nothing but collection of all transition probabilities. In general, it is denoted as P11, P12, P13, and so on, P1n. In general, we can generalize it as n by n matrix. P21, P22, P23, etc. Pn1, Pn2, etc. Pn. Okay, so it's a square matrix. Next, after transition probability matrix, we have to know the concept of probability in long run. So whenever time parameter is involved, we have to discuss about where the process reaches the steady state. Okay, so generally the process means it's a function of time. So as time varies, the process also will keep on changing. So then we have to discuss at what point it reaches the steady state. Okay, so steady state probability or probability in long run or excuse me, or we call it as stationary probability. Probability in stationary or stationary probability, or in other words, it's also called invariant probability. So many names, everything denotes it reaches the steady state or stationary state. Okay. So if they ask you find the probability in steady state or in long run or stationary or invariant, everything denotes pi. Okay. So how it is defined? It's defined as it's actually a row matrix 1 by n matrix, n depends on the number of states. If your TPM is of order 2, then for the corresponding transition probability matrix of order 2, the probability in long run is defined as pi, which is equal to pi 1, pi 2. If the transition probability is of order 2, then pi is of order 1 by 2. 2 by 2 matrix TPM, if TPM is of 2 by 2 matrix, then probability in long run will be of 1 by 2. Okay, so it is defined as pi is equal to pi 1, pi 2, and it satisfies two conditions. That is, pi 1 plus pi 2 will be equal to 1. That is, sum of the row element will be equal to 1, because this pi, all the entries denotes the probability. Same thing is true for TPM also. In TPM, how it is defined? It's collection of all transition probabilities, where each row denotes the probability. So here also, TPM also, sum of each row will be equal to 1, because we know total probability is 1, no? So sum of each row of TPM is also 1. Same way, here in pi, sum of the row, that is pi 1 plus pi 2 is equal to 1. And second condition is pi p is equal to pi. So P denotes TPM. Okay. So solving these two conditions, we can find the values of pi 1, pi 2, which gives probability in long run or in steady state, or stationary probability or invariant probability. Same TPM, same pi, how it is defined for TPM of order 3. If TPM is of order 3, that is, there are 3 states in the question, then long run probability is defined as pi 1, pi 2, pi 3. It's of order 1 by 3. With two conditions, that is pi 1 plus pi 2 plus pi 3 is equal to 1, and pi p is equal to pi. Solving this system of equations, we can get the value of pi 1, pi 2, pi 3. Okay. So in general, to solve the question given under Markov process, we have to be clear with two things. One is how to frame the TPM. Either TPM will be directly given in the question, or otherwise some description of transition probabilities will be given. Based on that, you have to frame the TPM P. So first thing, from the question, you should get TPM P. Next one, you need to know what is the initial probability. Initial probability denotes the probability in the initial stage. Either it will be given on 0th day or 0th state at time t is equal to 0, or sometimes it starts with time t is equal to 1. Either p of 0 or p of 1 we need to know. Either directly given in the question, or we have to get it. So after knowing TPM and initial probability, we can calculate whatever is being asked in the question. So if we are clear with few notations, it is easy to do the problem. What are they? If you are asked to find probability of any conditional, if conditional symbol is there, if conditional probability is asked, then this denotes transition probability. Already we have seen the definition of n-step transition. So if conditional symbol is there inside the probability, then denotes transition probability. Transition probabilities are nothing but elements of transition probability matrix P. Okay, so from P we have to get all these values. Can you say the notation for this? It has moved from state 1 to state 2. So it is 1, 2. In how many steps? 2 to 3. So number of steps it has taken is 1. So it is nothing but P12. So in the transition probability matrix P, we have to get P12. That is P11, P12. Second element is the answer. If suppose you have been asked to find P of x2 is equal to 3, given x0 is equal to 2. Then how can you interpret it? What is the equivalent notation? Conditional is there, means it is transition probability. So first we'll identify the state. It has moved from state 2 to 3. So P23. In how many steps? 0, 2. So number of steps taken is 2. So as we have TPMP, we have to find the higher powers, P square. And in P square, we have to identify 2, 3. 2, 3 means what? In the matrix P square, 23 means P21, 22, 23. So this entry is nothing but P23 power 2. So in this way, the question, if conditional symbol is there, we'll get the value from transition probability matrix or its higher powers. In other words, if the question is asked like find P of x3 is equal to 2, simply without conditional, only the probability value is being asked, specific value. This we can get only from the initial probability matrix, that is a row matrix, 1 by n matrix. Okay. So this we cannot get from transition probability matrix. So how will you get x3 is equal to 2? What does it mean? So this is nothing but the value of, if suppose we have a 3 by 3 transition matrix, then initial probability will be of 1 by 3. So either it can be p per 0 or p per 1. Now for example, we'll take it as time starts with t is equal to 1. P per 1 is given as initial. Then it is of order 1 by 3. Then x3, p of x3 is equal to 2 means what? So the state is 2. So this is state 1, state 2, state 3. State 2 means this entry, but x3 means you need p per 3. P per 1 is there. We have to find p per 2, p per 3. So in p per 3, we have to get the state 2 value. So this is the answer. If specific probability values asked, we'll get from initial probability and its higher power. If conditional, that is transition probability is asked, we'll get it from the transition probability matrix or from its higher powers. I hope now we are clear with the Markov process, Markov chain concept, the difference between those two, and how to solve the problems based on this Markov process. Thank you.